Hello everyone. In this particular video, we are going to solve the problem 1.9 from Irodov, and that is related to kinematics. So let us first read out the problem and then we'll solve the problem step by step. So a boat is there which is moving relative to water with a velocity which is n is equal to 2 times less than the river flow velocity. So basically let us say we are having the velocity of flow is equal to v, and then velocity of boat with respect to flow, it is given as v by 2. Okay, and it is asking to find the angle uh, at which the boat should move with respect to the stream direction so that the overall drift can be minimized. So let us first understand the meaning of drift. So let us say this is the river, and in this river the boat is here at, let us say, point O, and then this is point A at which the boat wants to move in the straight line. So this is the line in which the boat wants to move, and let us assume that there is no stream velocity. So if there is no stream velocity, then in that particular case the boat will move in this particular direction. Now let us consider that there is the stream velocity in this direction. With velocity, let us assume that it is v, and this velocity is v, then in that case it will move with the resultant vector in this particular direction, and it will end up reaching here at this point, let us say C, and then this particular distance A to C, this distance is called the drift. Okay, I hope the drift is clear. Now what the driver of the ship wants me to do, he is asking me to find the angle at which it should move so that the drift can be minimized. So I told that okay, you are moving with some velocity v in this particular direction with angle theta with the velocity of u of the stream, and then it was started moving in this particular direction. Now we know that if we want to move in this particular direction, then there should be certain velocity of the boat with respect to the flow and velocity of the flow and this particular angle theta. But it is not the case always when we can move in this particular direction. There will be some sort of the drift in the case when the stream velocity is very high and we don't have that much capacity of the ship to move with that particular velocity so that we can move in this particular direction. So in that case what we can do, we can minimize the drift instead of make the drift as 0. Okay, so let us consider that this is the velocity of the boat with respect to the flow, that is given as v by 2, and this is the velocity of the flow which is given as v. Now this is angle theta. So this particular angle will be 180 minus theta, and what is this component? This component will be v by 2 cos of 180 minus theta. So cos of 180 minus theta we know that is minus of cos theta, and this particular component will be v by 2 sin theta. Okay, so now if we take the component of resultant velocity, so this will be v minus of v by 2 cos theta, and this particular component will be v by 2 sin theta. Okay, let us say this is vx and this is vy. So this will equal to v plus v by 2 cos theta, and this is v by 2 sin theta. Now as the boat is moving with the velocity of ux in the x direction and velocity of vy in the y direction, then it will have the resultant velocity in this direction. Okay, now assume that this is the distance d is given, and as the ship is moving in this particular direction, it will reach this particular point C, and this is the point A. So this distance is drift. Let us denote it as delta. We can write as d is equal to velocity of y into time taken. So d is equal to, what is vy? Vy we have found out it as v by 2 sin theta, v by 2 sin theta into time, and then time, from here we can find that time is equal to 2d upon v sin theta. Okay, and then drift we can find, drift is equal to vx into time. So drift we can write, what is vx? Vx is equal to v plus v by 2 cos theta. So this is v plus v by 2 cos theta into, what is time? 2d upon v sin theta. So we will get from here 2 plus cos theta whole divided by sin theta into d. Now this is the drift, the equation of drift we got from here. Okay, so this is the drift equation we got, that is dependent on theta, and d is constant because we have assumed this particular distance is d. Now in order to minimize the drift, we have to differentiate the drift with respect to theta. So as we can differentiate d of delta divided by d of theta, we can write d by d theta of 2 plus cos theta divided by sin theta whole times of d. We know from the chain rule that d upon let us say d of u upon v is equal to v times d of u minus u times d of v divided by v square. We will apply the same here, sin theta as it is, d by d theta of 2 plus cos theta minus 2 plus cos theta into d by d theta of sin theta whole divided by sin square theta whole times of d. Okay, and then we will differentiate each term. So d by d theta of 2 is equal to 0, and d by d theta of cos theta is minus sin theta, and minus of 2 plus cos theta, and d by d theta of sin theta is equal to cos theta whole divided by sin square theta into d. And we will equate it as 0 because we want to minimize the drift. So we will get from here minus sin square theta minus 2 cos theta minus cos square theta whole divided by sin square theta, and we'll move the d from this to this side, and then on the top we'll get minus 2 cos theta. Sin square theta plus cos square theta is equal to 1, so we'll get this as minus 1 is equal to 0 as we will move this to this side. Then we'll get cos theta is equal to minus half. So from here we can get theta is equal to 120 degree, as it is negative in the second quadrant. I hope the entire procedure is clear. Thank you.